thank you all for coming. This is just a very preliminary presentation of our Eclipse expedition. Of course, there were lots of details and incredible preparations, but I just wanted to share with you just the highlights of some of the aspects of this eclipse. So this first slide is just a momentum of different memorabilia along the way. The bottom one is Carhenge in Alliance, Nebraska, and if you want to know more about it, I'll let you know. I can talk to you about it, and this is what people went out of their way to make some cakes that look like this size. Okay, so why, first of all, why do we go through all the trouble of chasing eclipses from a science point of view, when we have so many observations from space? So if you notice, these are combinations of eclipse images here and an image from space in the extreme ultraviolet. This is from another one that's a coronagraph. And you can see that the eclipse is the only medium or form that allows us to observe from the solar surface all the way out to several solar radii. There's nothing at present that allows this. And it's very important because all the variations and the changes in the corona happen within the first radius from the solar surface. So just briefly about the science. So there was a seminal discovery in 1869 made during a total solar eclipse, and that was at the beginning of spectroscopy. And it was this line that was called a coronium, that people called a coronium line because they didn't know what it was. And it took 70 years to identify it as iron that had been stripped of 13 electrons. So it had several implications. One, that the corona that you see during a total solar eclipse is actually very hot, at over 1 million degrees. And then Parker showed that it could not remain bound to the sun. And this was also, he came up with a theory of the solar wind. So what we are endeavoring to find during with our eclipse observations is we observe the coronium, but there are plenty of other spectral lines that we can observe. We can say something about the composition, the chemical composition of the corona, the distribution of the temperature in the corona, and also the abundance of the elements. So all this goes back to trying to understand why the corona is actually hot. The other thing that you can capture with a total solar eclipse is you capture the instantaneous state of the corona. So on the left side is an image from 2013, and on the right is the image from space, but of course you're missing all the inner parts here from this coronagraph. But using the space-based observations, you can then put the eclipse images in the context of what has happened in the corona. And in this case, there was a huge coronal mass ejection that was captured in the image. The other thing that we also found from our observations from 2006 all the way to now, but this composite stops in 2015, is that the temperature, so I should explain that the red is emission from iron 10, which is at around 1 million degrees, iron 11, and the green is from iron 14. So you can see that there's a significant difference between the coronal structures and the temperatures in the temperature which they are assigned to. The other very interesting bit of discovery was the fact that these red protrusions into the corona that are called prominences, which are dense chromospheric material, are always surrounded by the hottest material in the corona. And this is a kind of a puzzle that we still don't know. The other thing is, do we attribute this distribution? So the other thing is the sequence of observations covers almost a solar cycle. And that means it varies with the number of sunspots, but there's another thing that varies on the solar surface as a function of time, and that's the distribution of prominences on the solar surface. So our idea now is that actually it's the prominences that are responsible for the changes of the distribution of the temperature and the coronal structure. The other discovery that was made in 2015 with a spectrometer that Ali Ding designed was that there was actually, we captured a coronal mass ejection front, and embedded within this front were bits of cool material. And all these bits were traveling together at speeds ranging from about 100 to 1500 kilometers per second. And this is a mapping of these observations, so I don't need to go through that. So clearly then the eclipse of 2017 offered a unique opportunity to do observations from multiple sites. In 2012 we got clouded out, in 2013 we got clouded out, in Indonesia in 2016 we got clouded out. And the preparing for an eclipse takes a tremendous amount of work. It's like you're carrying your telescope to different parts of the country or the world, actually. So the original idea was to have maybe 10 observing sites across the country, but fortunately we didn't have enough money in some ways, because even having 5 was a horrendous amount of work. So we covered from Oregon all the way to Nebraska, to Alliance, Nebraska. So we had 5 observing sites, and the main reason for doing this was to maximize our chances of obtaining observations. So these are the sites, and we tried to have almost identical instrumentation in all of them. So the orange circle are these observations, and the blue was on Whiskey Mountain at 11,000 feet, where we had to limit the equipment we had. So these are the 3 types of instruments that we have used. The spectrometer here that Adi designed. We use these cameras with special filters, so we can select the different spectral lines in the corona, for example, the iron lines or argon lines, which we tried for the first time this time. And then you can image the corona in these spectral lines. And the other one is just having very high resolution white light images with cameras with different focal length lenses that give you a resolution down to at least 1 arc second. So we started here at the IfA. This is just the size of the equipment. Some of you might have seen us packing and so on. So half of the equipment was already in Boulder, and then this is one of the larger cases where we had to, ship the narrow bandpass filters. Usually we carry them on our back, but this time we didn't have enough Sherpas leaving from the IfA. This is then we went to Boulder, and thanks to Judd Johnson, we had access to an the Avalon, which is like a dance hall, huge. And we had enough space so that the 5, so you can imagine we had 5 observing sites, and we had, at the end, we had over 30 people who were the actual operators and the scientists at the different sites. So we needed a floor space that was big enough so that we could set up, make sure all the equipment, people knew how to run the equipment, test everything before we left. And we didn't have much time. Again, we were very limited by financial resources in this case, and I won't go into that. That's heartache. But anyway, this shows you, gives you some idea of how we were scattered. This is just one of the rooms that were available to us. And these are the different cameras and the people discussing. And here is one of our, the spectrometer that's opened up here. So this is, in case some of you don't know, this is Judd Johnston. This is Pavel Starha from the Czech Republic. He's from the Czech Republic. This is Gary Neat, and this is Rob Hadassy from Boston. Okay. So this is our group picture just before we left Boulder. Unfortunately, Judd was not there, and we thought, we decided that we would Photoshop him in it, but we haven't had the chance to do that yet. And these are the Armada of 4 motorhomes. So the way we decided to go to 4 of the sites is to rent these motorhomes because they have a large enough hall to put the equipment. But in addition, we also had at least 1 car accompanying the motorhomes to the different sites. The longest travel time was to Mitchell, Oregon, which was 1,200 miles each way. Alliance was a lot closer, so was Guernsey State Park. So then the other innovative piece of equipment that we had was this observing tent. So it was designed here. Judd and I gave the instructions. I found a colleague in China who could have them tailor-made, literally custom-made. And because the sun was going to be very high in the sky during the eclipse, and we had three types of equipment, so we needed to have windows that opened up to clear the zenith. So you see all these openings were actually plastic windows, and we just removed them just before totality. The other thing we have to have in our observing tent is an air conditioner, not for us humans, but for the equipment. So these tents held up fairly well. They sent us a prototype first, and Judd had to ask for certain alterations. And then the final ones, we had 4 of them shipped then to the US. Now, before we left, I'm sure most of you heard about the forest fires and in the West and in British Columbia. And the weather looked amazingly bad across the whole path of totality. This was mostly the smoke pattern across the US. And the last one is the prediction on the 21st. So we were all bracing for the worst, and fortunately it didn't happen. So this is again when we left. So the closest station was in Alliance, Nebraska. These were our hosts. And I must say that I try not to go to large cities or concentrations of people, because first you get the air pollution, and second it's nerve-wracking to have too many people around you when you're trying to operate equipment, getting everything ready in time. So these people had offered thanks to Trina, Rob Jadiki's wife, who found different people and hosts along the path of totality where we wanted to go. And they were extremely gracious, and they offered their huge property. This is one of the equipment, the white light, and you can see that they had to use a tractor to move it because it's so heavy. At first it was under an awning, but then the wind took care of that, and they had to do with a tarp to protect it. Okay. So this is Tulin from Azteco from Germany who's operating it. The mod is a production from that company. And this is, that group attracted, and Ben can tell you more about it because he was there. They attracted quite a few people, and the host also had a party in their honor. And they also gave a public lecture, so they were able to mix with the community, because Alliance is a very, very small town, but there was still, they could stay away from the crowds, at the same time they could engage with them. So this is Martina from Bridgewater State College, who's preparing to observe. And these are people in the tents. This is Ben. So just to give you, and this is apparently, obviously I was not there, so this is the day of the eclipse, so I collected pictures from people from all 5 sides, and it didn't look very good in the morning, but fortunately it cleared up, so it was really lucky, and this happened. So this is Ben. I don't know if it was before or after the eclipse.
Looks like before.
Before. So he had a tie-dye lab coat. And this is from a picture from the drone of the whole team. So you can see it's actually a nice picture that captures the tents as it's fully opened, and you can see everything inside it. So they had success, and this is one of the pictures they got. The second site going now further west was in Guernsey State Park. Again, they had yurts that allowed several people to be there. And this is the park on Eclipse Day. You can see all the cars in the background. And the rangers were so kind to the group, because they left everybody at bay, and we had our observing site without being interrupted by lots of people. So this is Natty was in charge of that site, and these are they're getting ready for the observations. So you can see how everything is quite open, and you might want to guess who this person is who was running the spectrometer. He was, so then they also gave a public talk, and Nancy did, and Mike and Keith chimed in, and it was extremely well received. This is the beauty of this shot is you can actually see the sunspots that were present on the surface, and this is just a little bit into totality. Now this picture was taken by Peter Horalik from the Czech Republic, and he processed it, so it just gives you some idea of the beauty of the corona once the image is being processed. And you see, this is almost what the eye can see, but with a camera you can't capture all the details. You need several exposure times. And this prominence was actually quite huge. This was the first time I managed to look at the eclipse, one of the few times, because somebody else was running the equipment. And to my eye, I could see chromospheric emission all around the sun, and I actually saw the moonshine. So, okay, so this is I hope this will work. Okay. So this is a video that Nati took, but it's a time lapse, and you can see how everything got dark during totality and then got lighter. This one is looking towards the east, behind the sun. So it gives you an impression of how the landscape gets darker. So there was some wind.
Yeah, quite a bit of wind actually.
This one is a lot longer, but you will see the darkening of the landscape.
It is nice. You can see the
the branch from the tree.
Yes, I know the thing, yeah.
It's starting to darken.
That was it.
I put
Darker.
yeah, and then you'll see Mount
Laramie.
Laramie will show up in the back once it gets dark. Stop.
It's stopped, isn't it?
Okay, never mind. I can show it later. Sorry about that. Okay, so this is that team. It's their group picture. And then we move on to further west to Whiskey Mountain. So this group consisted of 3 people. It was the most expensive to access because they had to go up on horseback. So this was at 11,000 feet, and they only took a very, very small group of people. So you can see the trail of the horsebacks, and on one of them, the equipment is on the backs of the horses. So we tried to limit it as much as possible. The other design that Judd came up with. Okay, so this is the site from inside the temple. Are these solar panels here for electricity to charge the batteries? You can see the horses in the back, and our. So here you have the panels right by the tent. And this is all the equipment that they took up to the mountain. So the largest container was actually this one, and they managed. Okay. Now we move on to Mackay in Idaho. This was a picture that I had taken a year before when I scouted the area, but I didn't have a landscape. I didn't get it in time to prepare this talk. So these are the 3 instruments inside. So there was a white light camera, the spectral line cameras, and this is the spectrometer. So this was a group from the Czech Republic, and you can see how they had on the screen of their laptops that are operating these cameras. They were able to see the beginning of totality, and this is the group. And finally, we come to Mitchell, Oregon. So this was the furthest west, where I ended up being with Judd, Eddie, and some And you can see the smoke was always, well, it was there and it was haunting us, and it made for gorgeous sunsets, but that wasn't good for eclipse day. So this is us also setting up the equipment inside the tent. So you can see the spectrometer is over here, and these are the different cameras with different features. This was a private ranch, about 18,000 acres. And this is the house where some of us stayed inside the house, some of us outside in tents. But this was the most remote, I guess. We didn't have any, we hardly had any visitors. This is Adi inside the tent. And this is a very nice shot because you can see the crescents on the back of the building. So you can see all the shadows of the crescents from the tree that was in front of the house. And this is a shot from inside the tent looking outwards towards the eclipse sun. This is a group picture. So we had a group of 2 women who are doing a documentary, and they asked us to also turn around and take a picture from our back. So these T-shirts were made by the University of Brno, and they had one fun typo which doesn't show here. It says 21st of August. Because they forgot to change it from previous year. Okay, so this is some of the highest resolution images we obtained from Mitchell. So this large prominence I told you, it's turned around. It was this one here, which has exquisite details, and there was a lot of activity on the other side of the sun. And these are the Bailey's beads, which show up just before, right at the beginning of totality, when the sun shines through the different valleys of and this is a preliminary white light eclipse image from that side. You can see the incredible details of in the corona, all the turbulence that's going on here that was captured. This is the very large prominence I mentioned, and this is the other one here. And finally, we managed to get the first image of Argent 10 in the corona. It was extremely faint, so it's this green emission that's very, very close to the sun. The background is just the white light to put things in context. Okay, and this is the 2 Sherpas who didn't stop working, who were exhausted at the end. So I'd like to close this. I went through very quickly, but you can ask questions. And so I'd like to close by acknowledging support for the expeditions from grants we got from NASA and SF. The IIS provided some limited funds, but they were very helpful. And Astelco also provided some funds. I'd like to thank Wayne and Faye for all their help with the travel and procurement. And of course, last but not least, all those Solar Wind Sherpas who made this expedition possible. Okay. So, do you have any questions? Yes?
I've expressed, and I've heard other people around the institute express interest in getting some of your pictures to make for gifts for Christmas and stuff like that. Can we find those on your website?
Not yet. These are hot off the press. You mean the I showed you here?
Yeah.
Yeah, I mean, you can have them in a few weeks, but then you just have to put the acknowledgement.
I'm not going to be doing Christmas presents for a little while. But it would be great. I think everybody at the institute.
Actually, NASA took our picture from 2015 and they put it as on their website. It's the main white light image, and they also used it for sunshades.
What's this time?
Yes?
So Shadia, with this beautiful good weather on all 5 sides, is there a chance that you can see changes in the corona over this stretch of time?
Yes, but we're, I mean, it's too early now.
Yeah.
We haven't, you know, I think it's the other one.
We lost the link.
Okay. I know many of you went to the eclipse to different sites, so I don't know if you want to share some of your experience. Rob, do you want to say something? No?
Shadia, this partial eclipse picture with the 3 sunspots that you showed, that's exactly how the sun looked from
From here? Yeah.
And I actually saw the 3 sunspots through a binocular. So that
Yes?
Are you going next year to South America?
It's not next year, fortunately. We need a break because this was just a tremendous amount of work. I've never done anything of this magnitude, and it took a toll on many of us.
So you are not going to 2019?
Yes, I said it's not next year, it's the year after. Yeah. Yes.
So how many eclipses have you seen? And just to confirm, you said that was the first time you were able to look up at the eclipse, and you
Yeah,
were
because usually I'm always busy with running the the equipment.
Right.
And even if they're running and you're not actually, running the laptops, I still I'm very nervous because I want to make sure I can hear the cameras going and everything. It's quite. You only have 2 minutes. I forgot to mention that this was 2 minutes 2 minutes and 20 seconds by the easternmost site. So it's over very quickly.
Yeah, I've never seen such serious faces. I was showing Natty too, because I took a lot of pictures. They were so serious during that 2 minutes. And then when it was over and they realized they got the data, it was just like this pure joy coming from everybody. It was really amazing.
Yeah. And what we found also from the people who managed to give, gave public lectures, and also myself when I have done it here, is that the public isn't so much interested in just seeing, pretty pictures. They really want to understand why we're doing it from a scientific point of view. And I think this is very heartening that there is so much interest from everybody as to, you're looking up at the sun and there's so much information you are able to collect. Yes.
Do you know where you'll be for 2024 yet?
No. I heard that Carbondale, Illinois, I haven't, was apparently clouded. I don't know.
It's 4 minutes, right? 2020.
Yes, yes.
I can say something about South
Yes.
Carolina,
Uh-huh.
which I didn't know anything about until a couple of weeks ago. I was in South Carolina on the path of totality, but for family reasons. And the weather there was not, statistically, it was going to be cloudy, 2 o'clock in the afternoon in August. But it turned out it was perfectly clear. And that's only the second eclipse I'd seen. The other one was the 1991 that went directly over Mauna Kea Observatory. And there's 2 things I'd forgotten. One is how the real darkness doesn't happen until right before totality. I mean, up until a few minutes, you don't notice anything, right?
Yeah.
And the other thing is how bright the corona is. I'd forgotten how bright it is. But I give a little different perspective. The following day, I took my daughter and 2 grandchildren to a nearby farm where the kids could go and see animals. So I asked them, what do the animals do during the eclipse? And the frogs stop croaking, the crickets start to chirp, okay? The hens roosted in the tree, and the sheep lay down and went to sleep.
In 2 minutes.
Yeah, it's really quick naps, I guess. Yeah.
And what did the horses
For us,
do?
it was the temperature, sudden temperature drop. That's even before it gets dark. The temperature dropped by a good 5 degrees, 5 or 10.
We had a problem we were in Newport, Oregon, right on the coast,
Uh-huh.
and the problem there is fog.
Yeah.
And we had a little bit of fog and then it cleared up. But then during totality, it started to build up again because of the temperature. But we could see the corona okay even through the thin fog. I sent a picture.
Yes.
Well, but for scientific purposes, it's a killer for us, for aesthetic reasons, yeah.
No, I mean, I was surprised that we could see the corona so well,
Mhm.
even through the thin fog.
So maybe one piece of information, Danny went back
Yes.
to Oregon the day before eclipse, and she actually saw the eclipse from Oregon. So
But she saw the partial. They
The
didn't go.
partial,
They
yeah,
didn't
that's
go
it.
to the
They
path
went
of
to the
the
totality.
to the path of totality. Yes.
And I saw totality in Willamette in Oregon, and just a little point on sociological observations. After the eclipse was over, immediately, it seemed that there was resentment and a sense of loss in the crowd, because up to the eclipse, when they were announcing 20 minutes, 5 minutes, etc., everybody was cheering and clapping, but nobody cared once the eclipse was over. Now, my question is, Shadia, you spent a lot of time preparing for this.
Yes.
And obviously there's going to be a lot of time put into the processing. What are the top 3 things in the data that's going to excite you most when you're processing the information?
Well, I think one is to extend the database we have in looking at the temperature variations in the corona and the structures. The other is there are lots of I don't know why this stopped. With the spectrometer, the first time we observed successfully, we discovered these cool inclusions, and now there seems to be indication also from the spectrometer. I didn't present them because we're still analyzing the data, that there is cool material in the corona, which is very, very surprising. So we'd like to understand how could cool material survive in such a hot environment. And we also, from the structures, the different, the structures you see in the corona are driven by the magnetism starting from deep under the solar surface. So we are hoping that combining the white light images and the images that give us the colors of the corona, that we can say something about the interplay between the plasma and the magnetic field. So we have a long enough database that now we're starting to come up with new ideas and new ways of looking at the corona that aren't typical.
Thank you.
You said this was the first time you observed the argon.
Yes.
Do you expect to see any structure in that?
Well, people had seen it, detected it as a spectral line in a spectrum, but they hadn't imaged it. I expected, given its temperature, but I know now it's clear that it's the abundance of argon that's very low. I expected to see more emission, more extended, because the temperature is around 1 million degrees, but it turned out not to be the case.
So you don't think that you will see any structure in it? Because you could see that on the picture you showed.
The
It's
picture was,
green.
the background was the gray was the white light, the green was the argon.
Yes,
It was very, very close to the sun. It's
Yeah.
very diffused. So we didn't see much structure. We still need to work on the data, but that was the first impression.
what did the horses do on Mount Whiskey? Did they
wasn't
lie
that
down
for-
and go to sleep?
I don't think so, but I have to ask the people who were in Whiskey Mountain. I forgot to ask them what happened to the horses. Any other questions? Okay, well, thank you all for coming.